Okay, so lightning, everybody loves a good thunderstorm, right?
Oh, yeah.
And you send over this excerpt from Lightning Nature's Fiery Superheated Phenomenon. And wow, just reading the intro, I am fascinated.
It's a really cool topic.
It is, so let's get right into it. What do you say?
Sounds good.
Okay, so lightning heats the air around it to 5 times hotter than the surface of the sun.
That's right.
It says 30,000 Kelvin,
Kelvin, yeah.
which for our Fahrenheit listeners is over 53,000 degrees.
Wow.
Yeah, and this happens in a fraction of a second.
A fraction of a second, you're looking at temperatures that are just mind-bogglingly hot. I think the surface of the sun is like 5,800 Kelvin for comparison.
Yeah, that puts it into perspective.
Yeah.
So how does it get that hot?
Well,
What is the science behind the heat?
it's all about electrical discharge. So you have this huge buildup of electrical energy in a storm cloud, and all of a sudden it finds a path of least resistance to the ground. And when that happens, the rapid release of energy creates those extreme temperatures.
So like a cosmic short circuit or something.
Yeah, kind of like that. And the air around the lightning bolt, it heats up so fast that it turns into this thing called plasma.
Plasma, the stuff that stars are made of.
That's right.
Wow.
Plasma is actually a state of matter where the atoms are stripped of their electrons, so you have these charged particles. And that's why lightning is so bright. It's basically a glowing column of plasma.
Wow.
And, thunder that we hear.
Yeah.
That's the superheated air expanding so violently and rapidly that it creates a shockwave.
Okay, so we've got this mini star kind of exploding above us.
Uh-huh.
But this heat has to have other effects beyond just the bolt, right?
Of course it does. One of the big things is that it creates nitrogen oxides in the atmosphere.
Oh, yeah?
Lightning's intense heat causes chemical reactions between nitrogen and oxygen in the air.
Nitrogen oxides, those are important for plants.
Exactly. They're a huge part of the nitrogen cycle.
Oh, right.
Plants need nitrogen to grow, but they can't just take it straight from the air. Lightning helps convert that atmospheric nitrogen into something that plants can actually use.
So lightning is like a natural fertilizer.
Yeah, in a way it is.
Huh. That's pretty cool.
There is a downside.
What's that?
Nitrogen oxides contribute to air pollution and acid rain,
Oh,
which can harm ecosystems.
yeah, of course.
It's a good example of how a natural phenomenon can have both good and bad effects.
Yeah, nothing's ever black and white.
Right.
So we talked about nitrogen, we talked about the environment. The outline also mentioned something about aerospace engineering. How does that fit in?
Oh, yeah. Lightning is a real danger for aircraft.
Oh, because it's so conductive.
Exactly. Remember that plasma we talked about?
Yeah.
It's incredibly conductive. So a lightning strike can really mess up an aircraft's electrical systems and even damage the structure.
Oh, wow.
Yeah. Scary thought.
Yeah, it is. What can engineers do about that?
Well, they've gotten really good at lightning protection.
Okay.
Modern aircraft have special shielding and grounding systems to redirect the current of a strike and protect the important parts. Understanding how hot lightning gets helps engineers design better materials and make planes that can survive these events.
That makes me feel a lot better about flying.
Yeah.
So we've learned a lot about lightning in this deep dive. Are there still mysteries surrounding it, things scientists haven't figured out yet?
Absolutely. We know the basics, but there's still plenty to learn. Like the exact way lightning reaches such incredibly high temperatures is still being studied.
Uh-huh.
And every lightning strike is different. The path intensity, how long it lasts, all those things depend on the atmosphere, and we can't fully predict them yet.
So much to learn.
Yeah.
This deep dive has really shown how awesome and complex nature is.
It really has, and it shows why research is so important.
Yeah.
The more we know about lightning, the better we can protect ourselves from it and maybe even use its power for good.
Okay, so to recap, we've learned that lightning heats the air to an incredible 30,000 Kelvin, 5 times hotter than the surface of the sun. This extreme heat is caused by an electrical discharge, and it has all sorts of effects, from creating nitrogen for plants to creating challenges for aircraft engineers.
Absolutely.
And even with all we've learned, there are still mysteries about lightning waiting to be solved.
That's the beauty of science. There's always more to discover, and lightning is a great example of that.
It really is, and studying lightning isn't just about understanding a cool phenomenon. It's about understanding our planet's atmosphere, its balance, and the forces that shape our environment.
Well said.
It makes me wonder if we could ever harness the power of lightning. What could we do with it? Could we find new energy sources or create incredible technologies?
That's a great question.
It is. It's something to think about the next time you see a thunderstorm.
Definitely.
Thanks for joining us on this electrifying deep dive.
It was my pleasure.
See you next time.